now we have a presentation from Dr. Miner. Nice to see you, Kelton. And Kelton is going to be giving his talk titled Heat Resilient Infant Sleep. Take it away, Kelton.
Perfect. And I just want to make sure that this is visible for you. So hopefully you
Yes,
can see
yes,
this.
perfect.
Okay, great. Perfect. And let me just double check. Is that changing on your side too? We'll just double check here. See here. Okay, let's try this. Great. Can you see the slides now?
Yes.
Perfect. Okay. Thanks so much. And thanks for bearing with me. I just put down my child myself. So this is all very, very relevant. And I'm really excited to present on some prospective work that's sort of in the pipeline entitled Heat Resilient Infant Sleep. Um, you know, a lot of the work that I do and research from, environmental health and also sleep research that looks more intensively at the environment has collectively revealed that the environments that we live in can also be viewed as experiments that are unfolding in time as well as in space. And you can think of these as sort of biopsychosocial ecological experiments that take place at different scales. If you were to go up into outer space, you would see this experiment on a very large scale unfolding in real time. And what's interesting is that one aspect of this global experiment constitutes temperature and anthropogenic changes in the Earth's climate system. And we can see that in global average temperatures. And I'm sure many of you have seen sort of plots like these that chart the recent trajectory that we've taken. But what's really interesting is that in the last 3 years, we've seen the three warmest years in the historical temperature record. In the sort of recent recorded record, in the sort of instrumental era where we've had really robust measures of temperature around the world. And I think what's important is that those global average temperatures translate into daily temperature anomalies, and those in turn are expected to increase in the future, such that, those three warmest year records that I just alluded to actually will be some of the coldest years that we experience for the rest of our lives. And where we, end up in terms of this Earth system and the temperature trajectory that we're on really depends on the sort of collective actions undertaken by, governments and individuals around the world. So those emissions decisions will sort of chart this trajectory. Now, it's not the global average temperature or even daily average global temperature anomalies that matter for our well-being and, daily life. It's really the stressors that they drive. And so I'm going to talk mostly about temperature today, but I want to be mindful of this broader context. And we recently published this climate ecological risk framework. So this is a psychosocial ecological framework that helps to weave together these different aspects into a conceptual mapping. And if you think about it, those climate stressors then intersect with, different groups of humanity through exposure. So that could be an extreme rainstorm or again a heat dome that, bakes a large population. And that exposure again interacts with the underlying vulnerability landscape. So those vulnerabilities, together with the exposure to these climate stressors, produces risks, and those risks can cascade through different aspects of our health and behavior and well-being. And that can include physical health burden, psychopathology, but also more macro destabilization of the social, economic, and environmental and political support systems that we have and are a part of. And in addition to this, these more daily incremental changes to behavioral patterns and other aspects of our mental states and neurophysiology. Now, these different impact pathways can impact human development across the lifespan. And, it's so important that we also focus on the early parts of the human developmental trajectory, which I'll be talking more about today. Now, those impacts can accumulate and impact educational outcomes. And in this review, we highlight multiple different ways in which this appears to already be taking place around the world. including the impacts of both chronic and acute exposures to heat wave events on student learning in early childhood. So this is something that we see, but what we don't know as much about right now are the specific mechanisms driving these impacts that we observe again in both high stakes and other sort of learning achievement settings. And so recently we conducted the first global scale investigation looking at the relationship between temperature and sleep in adults. This was a large scale study conducted in over 68 countries, or 68 countries specifically, and nearly 50,000 adults. We combined 10.7 billion minute by minute sleep state observations from accelerometry based sleep tracking wristbands with contemporaneous temperature data from weather stations all around the world, as well as a gridded satellite weather data set. And what's really interesting is that we find within individuals, the hotter the temperatures are, so if there's an unseasonably hot night of year in a given time in a given place, that people sleep less compared to their own baseline at that same time of year, but that the impact is nonlinear and becomes progressively larger on the hotter side of that temperature distribution. We found very limited evidence of adaptation, and thus we, performed a projection exercise where we found that without further adaptation, we would expect warming nighttime temperatures to not only erode the quantity of time that people sleep, but also in a more clinically relevant sort of lens, increase the number of clinically short nights of sleep, so less than 7 hour nights of sleep. And we also find the same relationship for less than 6 and less than 5 hours of sleep. So this was translated more recently into a global scale indicator where we actually can look historically at the recent changes, and we find that we do see evidence of a recent increase in the amount of sleep that is being eroded globally. We estimate that in 2024, there was a 9% increase in the temperature attributable sleep loss globally compared to the 1986 to 2005 climate baseline. So just to say in the recent period, we do see that there appears to be an increase in this impact. Now, we importantly are finding evidence now through other studies. So there was a recent study published by Lachat et al. In 2025 in the journal Sleep of the same functional form being reproduced using different methods and different wearables. This is from Withing's wearable data reported in over 50 different countries. And I think worryingly, we see that on that hot side, it appears that the warmer it gets, the progressively larger these impacts are. So without further adaptation, we expect that the sleep loss in a warming world attributable to climate change will not just increase, but may actually accelerate. And I think that's a really important takeaway here. We conducted a recent systematic review of the literature on temperature and sleep in environmental observational settings, so not in lab studies, but just looking at observational studies. And in this sleep epidemiological literature, we find that 81% of prior studies found negative sleep associations between high ambient temperatures and human sleep outcomes. And this literature is really expanding quite rapidly, but we still see really important gaps and disparities around the world in terms of which countries are being covered and which areas, including many of the areas that have both high levels of vulnerability and exposure to the risks in a warming world, are not yet covered. And I think that's a really important priority area moving forward. We also find that there's a need for more studies that include indoor measures of temperature as well as outdoor temperature, because those pathways may actually operate through different channels. And we also find a real dearth of evidence about what the impacts may be in early childhood. And this intergenerational aspect of equity is really important as we think about climate adaptation and making sure that we help those future generations cope with the warming world that we're already observing, but also what we expect to see in the future. So one really important exception here is the study by Berger et al., which was conducted using the Nanit platform in the 2022 summer UK heat wave. This was a massive heat wave event, and they found that on heat wave nights, infants had less total sleep, less efficient sleep, and more sleep latency. It took infants longer to fall asleep, and there's a bunch of other interesting outcomes. So I really encourage you to look into this paper if you're interested in some of the early evidence in this setting. But importantly, one additional motivation is really with that future mindset. If we compare, say, the current or say a 1960 birth cohort to a 2020 birth cohort, we can see that the lifetime heat wave exposure really changes by a factor. So we see that the 2020 birth cohort, we expect that they will experience anywhere from 4 to 7 times the number of heat wave events as that 1960 birth cohort. So, for me personally, 1960 is roughly around when my parents were born, and I was born in 1990. So I, will experience 3 times the number of heat waves in my lifetime compared to what they experienced. But for our children moving forward, and specifically the 2020 birth cohort, we expect that they will experience between 4 to 7 times as many heat waves, just to put that in perspective. Now, this is not the only motivation because nighttime temperatures are also warming faster than daytime temperatures across most areas globally. And this is a trend that we really see separate in the 1980s that has continued to grow in recent times. And so this I think really inspired us to ask the question, what about this infant sleep response? And so we recently received an American Academy of Sleep Medicine strategic research grant to look into this. This is work that's, in progress and is just about to kick off. So it's largely describing, the prospective work that is to come, but we hope to address these core questions. We want to understand what the sensitivity of infant sleep is to both indoor and outdoor ambient temperatures. We also want to understand how that relationship might develop across the sort of early stages of development and how it may differ across sex. And we also hope that we can better understand the protective factors, including environmental factors like air conditioning ownership, that may be associated with attenuated sleep sensitivity to ambient temperature, again, to inform those adaptive actions moving forward. And we intend to enroll a large sample of 2,000 infants aged 4 to 6 months from all 50 US states and the 6 largest Canadian provinces. And this will be a 12-month continuous enrollment period to ensure that we have staggered representation with enrollment across the course of the year in different seasons. And we also want to ensure that we monitor for a long period of time. And so this will be really testing out a new form of longitudinal monitoring of 18 to 24 months of nightly unobtrusive sleep and thermal exposure monitoring to ensure that we have really robust within infant variation in both their stages of development, but also the types of thermal exposures that they experience across seasons and across multiple years. And so this is a very large scale endeavor, and we intend to combine and link together that sleep and temperature and local weather data to conduct a natural quasi experiment to estimate not just the association between changes in temperature and sleep, but the causal relationship between those two variables. And I just want to wrap up by, invoking the imagery. This is from the most recent IPCC report, that, the extent and magnitude to which our current and future generations will experience a hotter world really depends on the decisions that we make now and also in the near term. And I hope this presentation has sort of driven that home through, this really important aspect of our lives, which is sleep. And, as we think about what we might do to address at least what we see with adults and what we don't yet completely understand with infants, we have to think both about adaptation and mitigation. And you can think of adaptation as treating symptoms that already exist, but we would be remiss to just treat symptoms, and that there's actually a role for both adaptation and mitigation, or primary prevention in this case, of the burden that really depends on our collective behavior. So thanks so much for your time, and I'm happy to take questions about either the prior literature or the work that we have planned.